But the vaguest rule applies here as well, unfortunately. What happens in the server stays in the server. Even though server-side mechanisms can be utilized for net positive results for privacy, performance, and data security, the very same mechanisms can be abused with far more capability for misuse than anything that could be run in the browser. This is the Technical Marketing Handbook, a podcast all about the thingamajigs and the shenanigans behind the world of technical marketing. Today our topic is web browser tracking protections. Enjoy the show. Welcome to another episode of the Technical Marketing Handbook. I'm your host, Simo Ahava, and I'm also the co-founder of Simmer, the organization that sponsors this podcast. In today's episode, I'm flying solo again thanks to the overwhelming positive feedback from the previous episode. At least 2 or 3 people specifically stated that they very much enjoyed just listening to me talk. So of course I'm completely now infatuated with that feedback and will proceed to do another solo episode. Hopefully soon we'll have another interview lined up for you. Today's episode is about browser tracking protections. And before diving into that, it's necessary to look at the background, why such things exist. So to protect the end user's right, the browser user's right to control their own data, browsers employ measures and features collectively known as tracking protections. With Apple's Safari browser being the pioneer, other major browsers such as Firefox, Edge, and Brave are also constantly developing new capabilities to playing this cat and mouse game with trackers. However, many of these protections are quite unelegant, which is a charitable way of looking at things, even so. As browsers seek to reduce the tracking surfaces that vendors are trying to exploit, these protections also disrupt very basic web flows, such as first-party measurement, using cookies or other browser storage to maintain state in a web app, and using third-party content distribution networks to load scripts or other value-added content. Particularly in online analytics, many of these tracking protections have been received with trepidation. Even though I suppose most of us understand the need to prevent the data collection and exploitation mayhem that has been allowed to progress for years unchecked, the impact it has on web development, online analytics, online advertising, and maintaining an open web isn't always positive. In this episode, I'll explore and share details about the technical means by which browsers and browser engines limit or attempt to limit a site's capability to track its visitors. Before we get started, though, it's important to define what browser tracking protections actually are. This is the definition I've come accustomed to using. Browser tracking protections are default browser settings designed to protect the user from tracking vectors that can be harmful, which the user has traditionally only been able to opt out of. Now, digest those words as we take a small detour to listen to what our sponsor has to say.
Are you a marketing or a data professional looking to skill up? Take a look at the online courses Simmer has to offer at teamsimmer.com. The courses are completely self-paced and your enrollment will grant you lifetime access to the material, including any updates. Go to teamsimmer.com and use the coupon code HANDBOOK to get 10% off your course purchase. That's teamsimmer.com.
So as I said before the ad, browser tracking protections are default browser settings designed to protect the user from tracking vectors that can be harmful, which the user has traditionally only been able to opt out of. Let's dissect this. By default browser settings, I mean that they are enabled by default on a fresh browser install. Now, many browsers offer additional layers of security and privacy, but they require the user to toggle these enhancements on through the browser settings. There are also ad blockers and other browser extensions and tools that the user can install to further aid in avoiding this tracking from happening. But these are all opt-in mechanisms. They only serve a marginal population of users who are savvy enough to know what they're looking for and to install them in their browsers. So that's why when I talk about tracking protections, I want to focus solely on the default browser settings. These impact all browser users except a very small portion who have decided to opt out of tracking protections. These settings are designed to protect the user. With protect, it means that the browser is taking an active stance to shape the user's web experience. Now, there's nothing new in this approach. Browsers constantly strive to optimize the user's access to web content and how it's rendered, for example. But the main difference to other optimizations is that while performance and accessibility and security enhancements are often fairly easy to find consensus for across browsers, the notion of suppressing tracking is far more difficult to find agreement on. First, who gets to define what tracking means? There's no general definition for this. It's not a legal term either. Even more confusingly, browser vendors' definition of tracking seems to change with time. For example, Apple's original definition of tracking when it comes to their intelligent tracking prevention mechanism was defined as cross-site tracking, or the way that ad vendors want to track a user's movement from one website to another. But today, for Apple, tracking seems to mean any type of data collection that happens on a site, regardless of if it's used for cross-site purposes. Now, it's an understandable shift, of course, as vendors are scrambling to move from cross-site tracking to same-site tracking, only to build the cross-site profiles later in their servers. But the lack of a commonly shared definition certainly makes things harder for those of us who would like to see some consistency in not just the terminology but the implementations as well. Finally, tracking is something that has typically required opt-out rather than opt-in. Before, if you didn't want to be tracked on any given website, you'd need to install an ad blocker, or you need to go to the browser settings to disable third-party cookies, for example. With browser tracking protections, it's the tracking protections that require opt-out. If you want to allow vendors to track you across sites, you can go to your browser settings and disable the tracking protections. This should cater to those people who still say they actually want better targeted ads. With this definition now serving as the backdrop, let's see what browser vendors are actually doing. All discussions about tracking protections need to start with Apple. After all, Apple's Safari was the first major browser to deploy some type of tracking protections, and they did it already in 2003 with their first stable version. Apple's original tracking protection is known as their cookie policy. This policy stated that third-party cookies are blocked unless the user first visits the third-party site and allows it to set a cookie in first-party context. But hold on, third-party cookies, first-party cookies, what are these? Cookies are small bits of information that a website can set on the user's browser. The original purpose of a cookie is to help with the statelessness of the web. Without a mechanism such as that of cookies, any information on a web page is lost once the user navigates away from it. With cookies, this information can be persisted from one page to the next. Now, first-party cookies and third-party cookies are somewhat of a misnomer. There are just cookies. An individual cookie has no encoding about whether it's a first-party cookie or a third-party cookie. But there's first-party access and third-party access to these cookies. When we talk about first-party access to a cookie or first-party cookies, we mean that the browser is actually browsing the site where the cookie is set. So while I'm browsing on teamsimmer.com, for example, any cookies written on teamsimmer.com can be accessed in first-party context, and they are thus first-party cookies. Third-party cookies are cookies written on some other site than the one I am browsing on. So while on teamsimmer.com, if my browser makes a request to fonts.google.com, for example, to download a web font, then any fonts.google.com cookies included in that request will be accessed in third-party context and will be considered third-party cookies. Most tracking protections, including those of Apple, target these third-party cookies specifically, as they are what vendors and sites use for determining cross-site navigation paths. In 2017, Apple released the first iteration of their intelligent tracking prevention. With this mechanism, additional blocking was introduced to third-party cookies if ITP flagged the third-party domain as having cross-site tracking capabilities. Now, this was fairly innovative as ad blockers, which had been popular for a long time, relied on a prescriptive block list and filter list, which required the tracking domains to be listed in an ever-expanding text file of domain names. But ITP instead algorithmically tried to determine if a domain is a tracking domain or not. If a domain was flagged, then any communications with that domain while in a third-party context would have these cookies stripped out. Now, ITP has gone through many iterations over the years, and as it stands today, the Safari browser blocks all third-party cookies without exception. So the intelligent part of tracking prevention has actually lost quite a bit of intelligence as Apple has opted in for a more brute force tactic. The only way to access storage in the third-party context today is to use something called the Storage Access API. Importantly, WebKit, which is the browser engine Safari is built on, is now the main driver in Apple's tracking protections features. All of WebKit's tracking protections are enabled in Safari and practically on all web browsers running on iOS. So even if you use Chrome or Firefox or even Brave on your iPhone, it is still just a WebKit skin and subject to WebKit's tracking protections. WebKit's tracking protections cover many other things in addition to just cookies. They prevent third-party access to any other types of browser storage as well. They prevent information from leaking out in the refer string, which denotes the page that brought the user to the current page. They prevent so-called bounce tracking, where redirects are used to collect and enrich additional information about the user. And they even breach first-party cookies and first-party storage with their restrictions too. Now, it's this last point that got the online analytics world to wake up sharply from their data-driven dreams. But to understand the move to first-party tracking preventions, it's important to know why this came to be. When vendors such as Facebook found their third-party cookies to lose efficiency, they started to move their cross-site tracking logic to first-party context instead. And how do they do that? Well, for example, when you are logged into Facebook and you click any link whatsoever, that link gets appended with a click identifier that contains information about your identity as Facebook knows it. Then when you enter the site at the end of the link, Facebook scripts or their partner scripts can take this identifier and report it back to Facebook, telling Facebook that you just visited the site. No third-party cookies are required whatsoever. So to prevent this, WebKit also restricts the lifetime of first-party cookies, making it difficult to attribute conversions to an ad click, for example. The lifetime restrictions apply specifically to JavaScript set cookies, and any such cookies are set to expire within 7 days of their last reset. Now, this is pretty dramatic considering the default lifetime of many analytics cookies, for example, is counted in years rather than days. WebKit can also detect if a third-party endpoint is masquerading as a first-party site by means of DNS cloaking, so manipulating the domain name system, and neuters cookies set this way as well. The most important takeaway here is that with WebKit browsers, all types of tracking is suppressed. Cross-site tracking is extremely inefficient, and even first-party analytics is difficult to do without persistent identifiers. There are workarounds, of course, such as moving to a more server-oriented setup, as cookies written in server responses are not subject to WebKit's limitations, at least today. So creating server-side proxies has certainly become a tempting option. All the other major browser vendors that deploy tracking protections have taken a slightly different approach. Brave, Firefox, and Edge all utilize filter and block lists to determine whether a given network request needs to have its capabilities of carrying cookies stripped out. Now, we discussed these block lists extensively with Pete Snyder from Brave in episode 2 of this podcast, so I recommend you listen to that for more information. But the key thing is that these 3 browsers have decided to improve the web experience by only limiting tracking access from endpoints that are known and verified to actually be trackers. Note that because of a lack of definition of tracking, these block lists often get things wrong too, so they need to be constantly amended and updated. The way the block lists work is that if any network request on the site is found to match a domain in one of these lists, then the request is either outright blocked, such as on Brave, or its capability to carry cookies is removed, which is what Edge and Firefox do. Firefox and Edge seem to be the most relaxed when it comes to tracking protections, most likely to avoid issues with web compatibility. Edge in particular has mitigations in place to allow tracking even if the domain is in the block list, in case the user is engaged with the blocked site, for example. Brave is a bit of an oddball here. Their whole premise is to be the most aggressive and gung-ho browser when it comes to deploying tracking protections. They were the first to block all third-party cookies outright, and they block the entire request if it's matched in the filter list. They delimit first-party cookie expiration just like Safari does. They block requests on a DNS level if known tracking domains are masquerading as first-party sites. They strip almost all information from referrer strings, and they even strip URL parameters such as Google's and Facebook's click IDs from the URLs themselves. Obviously, this aggressive stance has led to a lot of breakage on the web, because actually blocking requests can often lead to blocking script loads that have other purposes than just tracking. So a lot of Brave's work has gone into adding exceptions to these rules, but they are also working on more sophisticated means and heuristics to improve tracking protections without destroying the usability of the web. And again, we talked about some of these things with Pete in episode 2 of this podcast. Now, you might have noticed that I haven't mentioned Google Chrome in the context of tracking protections. So what about this, the largest browser on the market? Well, to this date, Chrome hasn't deployed a single feature for the purpose of tracking protection. They've certainly deployed features that reduce tracking surfaces, such as removing information from the referrer string by default and requiring third-party cookies to be flagged as such. However, all of these can be trivially worked around by ad vendors, and they don't really play into the narrative of default tracking protections where the browser is trying to protect the user's right to privacy. However, Google has loudly declared that they are in the process of removing third-party cookie support from the Google Chrome browser. They plan to do this by means of the Privacy Sandbox, a collection of features that strive to replace third-party cookies with new browser mechanisms that protect the user's right to privacy. The problem with Chrome is that the browser is run by a company that also hosts one of the largest ad networks on the web. There's so much vested interest in keeping the functionality of third-party cookies alive that any submission from the Privacy Sandbox team has been met and will be met mostly with cynicism and scorn. It's really a damned if you do, damned if you don't situation. Chrome can't just remove third-party cookies at the snap of their fingers because they would drown in the number of antitrust cases that would emerge when they remove their competition's chances of collecting cross-site data while still maintaining plenty of mechanisms to do the same by themselves. And once Chrome eventually does remove third-party cookie support, any replacement they've designed will always be met with scrutiny and will be very unlikely to emerge as a shared web standard. Our only hope as browser users is that the major browsers will work together to build a future where the open nature of the web is not compromised entirely. It's a fallacy to think that third-party cookies or similar functionality is necessary for advertising to work, but it's also very difficult to conceive of a world without targeted advertising built with cross-site audiences, as there's very little incentive and opportunity to proof of concept something like this, so that the results could be extrapolated on a global scale. So what next? Will browsers continue to play the cat and mouse game with ad tech vendors? Will server-side tracking or server-side tagging prove to be the solution, since it's specifically client-side or browser-based tracking that's causing all the trouble? Well, even though it might feel like we are constantly deprived of more and more mechanisms to collect data, whether with good or bad intent, it's also important to understand that what we are looking at right now is an overcorrection of gigantic scale. Advertising and marketing technologies have relied for decades on unrestricted access to user data through the browser. Even though, for example, in the European Union, there's been legislation trying to rectify this at least since 2002, it's done little to hamper this global harvest. So what both legislation and browser feature engineering are doing now is adjusting the scales dramatically in the opposite direction to shock the industry into figuring out new, hopefully more privacy-preserving means of collecting data responsibly. This overcorrection will end at some point. Things will level out, and new browser features will be introduced which reinstate our access to data with the full informed consent of users. But judging by the often acrimonious dialogue between browser vendors, regulators, ad tech lobbyists, and end users, it's difficult to see when things will level out. There are still many features being planned by vendors such as Apple, which will make it even more difficult to collect even first-party data. However, server-side might be a good idea nevertheless. Server-side gives the site more control over the data flows, as instead of allowing them to pass unchecked between the browser and the vendors, they can be validated and, if necessary, blocked by the server. But the Vegas rule applies here as well, unfortunately. What happens in the server stays in the server. Even though server-side mechanisms can be utilized for net positive results for privacy, performance, and data security, the very same mechanisms can be abused with far more capability for misuse than anything that could be run in the browser. So I have 3 recommendations for people struggling to operate in this reality of tracking protections, regulations, and the unbridled complexity of the ad tech world. First, always err on the side of the browser user. When trying to think of mechanisms to improve your data collection capabilities, try to think, is this in the best interest of the user? Respect their consent settings, respect their desire to block advertising and analytics processes, and respect their right to choose how their data is collected. Second, stay alert and follow the news. If you are working in digital analytics or marketing, you absolutely must understand how browser tracking protections and the digital advertising ecosystem work. You don't need to know it on a white paper level, but you need to know what the impact of these things is on your daily work. A good starting point is the cookiestatus.com website, and the show notes also include other resources you might find helpful. And third, measure the impact. Rather than lament on all the data that you're losing, measure the size of your WebKit cohort. Measure the number of times cookie consent is refused. Measure how much ad blockers are being used on your site. Use these measurements to calibrate your data analysis so that you know how much the data that you do collect is impacted by all this. Remember that when working with data, we are only ever working with samples. Our main job is to make that sample as representative as possible. It doesn't always mean we need more data. It means we need to know the parameters and the limitations that impact how that data was collected. There's a future in filling these gaps with machine learning where the algorithms are trained with data that was actually collected. This is what Google is doing with their consent mode feature, for example, and I believe more and more vendors will employ a similar tactic to regain information lost in this maze of tracking protections and consent pop-ups. This is all I have to say about this topic for now. We will, of course, return to tracking protections and browser engines and what browsers and legislation is doing in future episodes. Thank you again for listening to this podcast, and we'll be back in 2 weeks' time with another episode.